Good afternoon. Welcome to this new video. This is video number 395. In this video, I am going to answer a question: what is the difference between coefficient of correlation and chi-square test? This video is intended only for the beginners who may not necessarily have advanced knowledge in statistics. Kindly watch the complete video up to the end so that you could understand the concept and the difference between the two. Although the coefficient of correlation shows the strength of the relationship between two quantitative variables, and similarly chi-square test statistic measures association between two qualitative variables. So there is a natural question: what might be the difference between the two? So I am going to answer this question. Here is the presentation scheme. We will check definitions of both the coefficient of correlation and chi-square. We will also check the hypotheses of coefficient of correlation and chi-square test, and we will also discuss the range of values taken by coefficient of correlation and the chi-square statistic, and then we will also discuss some of the limitations of both statistic, that is the coefficient of correlation and chi-square statistic, and finally we will conclude this presentation. So we'll start with the correlation coefficient, and first of all we will define it. The correlation coefficient, denoted by small r, is a measure that quantifies the strength of linear relationship between two quantitative or numeric variables x and y. Chi-square test statistic, on the other side, is a non-parametric test which is used to measure association between two categorical, descriptive or qualitative variables. The chi-square test of independence assesses whether observed frequencies are different or contingent upon certain conditions or not. Here are the hypotheses of the coefficient of correlation. The null hypothesis for the coefficient of correlation test is that there is no linear relationship between two quantitative variables x and y. The alternative hypothesis for this test is that there is some relationship, some linear relationship between x and y, which are quantitative variables. For chi-square test statistic, we have the following hypotheses, and we start with the null hypothesis. And the null hypothesis states that the two categorical variables are independent of each other. That is, there is no relationship or no association between two categorical variables. The research hypothesis or the alternative hypothesis of the chi-square test statistic states that the two variables are related to each other, they have association. That is, there is a relationship between the two categorical variables. Now here we will discuss the range between which the coefficient of correlation varies. So the value of coefficient of correlation varies between -1 and +1, and we can write this like this inequality: -1 is less than or equal to r is less than or equal to 1. That is, the value of r ranges between -1 and +1, and both -1 and +1 are inclusive of this range. So it means that r could be -1 and r could be 1, or r could be 0, or it could be greater than 0 but less than 1, or it could be less than 0 but greater than -1. The value of r cannot go out of this range. So it means that the value of coefficient of correlation cannot be more than 1 or less than 1. That is, it cannot be 1.2 or 1.3 or 1.4. Similarly, it cannot be -1.1 or -1.2 or -1.5 and so on. So the value of coefficient of correlation will strictly be lying between these two extreme values of -1 and +1. On the other hand, the chi-square test statistic value will in most cases be positive. It will be positive because we divide the difference of the squared of the observed frequency minus expected frequency divided by expected frequency. So this test statistic, that is the chi-square test value, will in most cases be positive, but it cannot be negative because the nominal variables or the categorical variables don't have directionality. There is no direction in nominal variables. In some cases, the chi-square test value could be 0, but it would be equal to 0 if and only if the actual data and expected data are identical. That is, if there is no difference between the actual data and the expected data. If the computed chi-square value turns out to be negative, then we might want to check our math. Then that would be just a mathematical problem. I mean, there will be problem in computation or in calculation. So it is not possible for a chi-square value to be negative. It could be 0 only and only when the expected data and the actual data are completely identical. So in most cases, the chi-square value will be positive, but the value of correlation coefficient could be negative and it could be positive, but it will vary within this range of -1 and +1. It cannot go out of this range. There are certain limitations of coefficient of correlation and chi-square. The first limitation of the coefficient of correlation is that R cannot determine the non-linear relationships between the two variables. It only quantifies the linear relationship between the two quantitative variables. Secondly, the coefficient of correlation does not distinguish between the dependent and independent variable. We are not sure about which variable is dependent and which variable is independent, but it only quantifies the relationship between the two variables. Another limitation of the coefficient of correlation is that outliers or extreme observations strongly influence the value of the coefficient of correlation. For example, if we include one outlier in one series or both of the series, then the value of the coefficient of correlation will change a lot. Correlation doesn't imply causal relationship. That is, a change in one variable causes a change in another. So it doesn't necessarily imply a causal relationship between two variables. There are also certain limitations of the chi-square. First, the chi-square test is very sensitive to a sample size. If a sample size is very large, then even a trivial relationship can appear to be statistically significant. So when using the chi-square test, we should keep in mind that statistically significant does not necessarily mean meaningful. So this is very sensitive to sample size. Secondly, we must remember that the chi-square test can only tell us whether two variables are related to one another or not. It does not necessarily imply that one variable has any causal effect on the other. So the last limitation of the chi-square and that of the correlation coefficient is common. Both of them shows relationship between two variables, but they don't necessarily imply causal relationship between two variables. That is, they don't necessarily imply that one variable has any causal effect on other. So the question is, what do you mean by causal relationship? So I'll give some examples of causal relationships, and we can see here this is cause and effect relationship between the variables. So smoking causes lung cancer. So this is a kind of cause and effect relationship. Similarly, heavy rains cause flooding. This is also causal relationship, where heavy rain is the cause and flooding is the effect. Similarly, irregular to class, that will cause poor performance in the class or in the exam. So similarly, number of hours worked and the amount of money income earned, that is also cause and effect relationship. So ladies and gentlemen, in this video I try to explain the main difference between the coefficient of correlation and the chi-square test statistic. And as you remember that coefficient of correlation is used for quantitative variables, whereas chi-square test is used for categorical variables. The range of the values vary between -1 and +1 for coefficient of correlation, where the chi-square test will in most cases be positive. It cannot be negative at all, and it can only be equal to 0 if the expected data and the actual data are completely identical, and both of them don't necessarily imply any causal relationship between two variables. I hope you enjoyed this video lecture. If you have any question, you may ask your question in the comments below, and I'll try my level best to come up with the answer. If you haven't yet subscribed to this channel, kindly subscribe to the channel, but do not forget to click on bell icon